Hello and welcome back to Mr. Abden's Mathematical Adventure, Take 2. The last one wouldn't keep the correct orientation. I'm not going to upload no vertically oriented mathematical videos. Alright, here we go. Quick lesson. When we left off, we were talking about functions, rational functions. Things that look like this. Some sort of polynomial expression on the top. But then divided by another polynomial expression, like let's say x squared plus 3x. So we're cruising along, we have some values of x and we're outputting values of f of x, and they're flying all over the place. Let's just check what happens if you put 10 in there. 100 plus 50 plus 6, 156 divided by 100 plus 30. So it would be 156 divided by 130. That's a cool output. And, cool things happen as you start to get close to numbers that will either make the top 0 or the bottom 0. But what we're going to focus on actually is forget that it's a function. Just look at it as a mathematical expression. How can we manipulate it? How can we rewrite it or simplify it? How can we get a simpler view of what's going on here? These are pretty two complex polynomials, and then we're combining them with division. Well, one thing we can do is factor the top and rewrite it as two linear factors, which are simpler to understand. So let's see, there's x times x to make the x squared. We need to multiply to 6. That could be like -6 and -1, but that doesn't add up to 5. It could be -2 and -3, but that is up to -5. So they must be both positive. So when this sign is positive, the signs match, but that doesn't mean they're both positive. They could be both negative, but in this case they're both positive because it adds up to positive 5. Alright, let's speed it up because this is getting boring. What about the denominator? Well, in x squared and 3x both contain the quantity x. So really we could distribute the quantity x into a simpler expression, the x and the 3. And the fact that they both need to have another x in them is now represented by this multiplication. Alright, now we have an interesting situation. There's an x plus 3 on the top, and there's an x plus 3 on the bottom. What does that mean? Well, let's just say x is 10. That means that quantity would be 13, and that quantity would be 13. 13 divided by 13 is 1. So you're multiplying by 13 on top, but then dividing by it later, which does nothing. Multiplying by 1 and dividing by 1 doesn't change the quantity. What about if x was 20? Then it would be 23 multiplied on top, but then later divided by 23, undoing it. Again, doing nothing. So these aren't doing anything. We can simplify them to ones that don't do anything. But before we cross that out, what happens if x equals -3? If x was -3 before, this quantity is 0. And 0 times x, which was -3, is 0. But 0 times anything is 0. So there was a case where we could not have x be -3, because that would mean dividing by 0. Earlier when it was 13, that's fine. 23, that's fine. But this quantity being 0, that's not okay. So when we rewrite this down here, we have 1 and an x plus 1 times x plus 2 is x plus 2. And on the bottom, we have x times 1, which is x. So that's our simplified expression. But x cannot be -3 from that fact earlier. So there's really two parts of these simplified expressions. There's the simplified expression, and then any facts that may have been removed through the process of simplification. Let me try to figure out another way to say that. Oh, here we go. You may also notice that x cannot be 0. Right? X can't be 0. Can't be -3, but it also can't be 0. But your fellow mathematicians will see that and notice, obviously, x cannot be 0. But what can they not see? They cannot see this other fact because we removed that fact when we simplified it. Now, and everybody would rather have this expression because these are identical. Remember, whenever, except for -3, whatever x is doesn't matter because it cancels itself off. So it's an irrelevant expression. The only relevant factoid from that being part of the expression is this right here. So we've simplified it. This is way better. This is a way better expression, simpler to understand. The numerator is always 2 bigger than the denominator. But we have to also remember, according to the original information, x cannot be -3. All right, one more example. This is take 2, so I'm going to reference earlier work. This one better be good. This one's longer than my first take. Oh, more jokes, I guess. All right, here we go. What if we had 12x to the 7th? Sorry, 12 times x to the 7th times y to the 3rd. And we divided that quantity by 3 times x squared y to the 7th power. Now, right away, we notice that the numerator is 12 times bigger than the denominator. Whoop, I misspoke. It's not 12 times bigger. It's only 4 times bigger because the denominator's quantity is getting multiplied by 3. And so relative to the numerator, that's only 4 times bigger to be the numerator. In other words, you can actually divide these coefficients. These coefficients that we write larger, they do not contain any variable information. They are just coefficient information. 12 divided by 3, we can do that. That's 4. That's our first step. And then it gives us a home for everything else. 4 in the numerator. Some people like to do it like this. And this is a 1. But I'm not going to write that 1 later. Okay. Yeah, what can we do here? We have x times itself 7 times, but then dividing by itself twice, that takes it down to x times itself 5 times only. And then let's do a little mini game over here. Y cubed is y times y divided by y times y times y times y times y times y times y. That's the y to the 7th. It's a little mini game, okay. Y divided by itself, 1. Y divided by itself, 1. Y divided by itself, 1. There's 4 powers left on the bottom. Okay, here's our new more simplified expression. Didn't need such a long division bar, I guess. Ratio bar, whatever you want to call it. But x cannot be 0. You can't see that fact down here. The x is gone in the denominator. It's been simplified away, which is fine. It doesn't change anything. We simplified it away because it's irrelevant. If there are 7 powers of x on top and 2 powers of x on the bottom, then that's just these 2 powers of x on the bottom are not doing anything except to make the top behave like x to the 5th, which we have represented x to the 5th. We have that. But the part we're missing is x cannot be 0 because of the original expression where you cannot put a 0 in for x. And likewise, you notice y cannot be 0, but you notice that, so we don't need to write that down. We only have to write down the other one, which you can no longer see in the new fancied up expression. Okay, that's long enough. Don't forget to like and subscribe. See you guys in the next video.